It seems that I finally found an honest theoretical physicist to talk to. This is a sophisticated theoretical physicist and astrophysicist. I am elated. There are many physicists in my network. My work touches their prior education. I always hope that one or all of them will object to my ideas and say something such that a scientific discussion could ensue. That never happens. Some of my Jewish friends take offense to me challenging their idol, Albert Einstein. To them I have this answer: it is time to get a new idol. By the way, am I chopped liver? A long time has passed since we last communicated. I improved the theory when I tried to work with binary pulsars. I had to use the full version of my theory's laws of nature. I tried to use approximations in the past. Fortunately, the center of mass, two-body problem simplified my force. I used the new formulation to recover the planet's precession and to predict the binary pulsar's precession. I showed that GR is a very limited model, valid only for R equals m1 divided by m is equal to 0. It doesn't work for R close to 0.5 as it is in the binary pulsars. I also applied my theory to the merger of binary black holes GW231123. I would love to hear your take on my work. You can see the force I derived from first principles. Cheers, Marco Pereira. These are the law of gravitation I derived from first principles. It looks like the empirical Lorentz force for electromagnetism. That is not a coincidence. That is because both forces result from the same metric waves, Dieulaton field, and the application of the quantum Lagrangian principle, QLP. The difference is in the coupling parameters. Gravitation is epoch-dependent and electromagnetism is not. Here are the Who predictions for planets' precession rates. It is clear that Who predictions match observations, general relativity predictions, and observed or calculated precessions. Here we can see the R dependence of Who precession predictions. R is the ratio between m1 and the total mass m. Here are the binary pulsars predictions with the semi-major axis, and the total mass m scaled by n lobes. General relativity prediction is radians per orbit. The plot shows precession in degrees per year. If one changes the period, GR prediction, which was fitted to work with the unscaled, and m, shifts away from the observation.
The theoretical physicist speaks. Dear Marco, thank you for sharing your recent work. I had a look at the Who formulation and the figures you sent, they're quite intriguing. I see that in the solar system regime, your predictions align closely with both observations and GR, which is encouraging. But what's particularly interesting is the behavior in binary pulsars. The plot you showed indicates that Who matches observations more closely than GR does, especially at higher mass ratios. Out of curiosity, could you clarify which observational data or source you used for the binary pulsar precession rates? Also, have you done any uncertainty analysis to show whether the deviation from GR is statistically significant?
Dear astrophysicist, this spreadsheet contains the information I used in my calculations. From your question, I can see that, like everyone else, you think that GR makes predictions about binary pulsars. Unlike planets, orbital parameters for binary pulsars are not known. We cannot observe A, M, M1, M2. Supposedly, we can observe E, eccentricity. I assumed the eccentricity was correct in my calculation. So, you have three parameters left, A, M1, and M2, and you need three equations to determine them. One of them is Einstein's prediction of precession in radians per orbit. The other two equations are Kepler period PB and Peters-Matthews orbital decay dA, dt or PB_. Here we have Einstein's precession in radian per orbit prediction. The third Kepler's law for period and the Peters-Matthews equation for the derivative of PB with time or PB_. This parameter can be provided in microsecond per second or millimeter per day. Their three formulas are used to fit the three leftover orbital parameters m1, m2, and a. Eccentricity is measured in the time of arrival data. The precession observations and predictions are in degrees per year. That distinction is essential. So, now that you know that GR is not predicting anything, it is just one of the fitting equations. As a fitting equation, it will always be 100% correct, infinite precision. Hence, asking about deviation, statistical significance, misses the point. Precession, degrees per year, is observed. PB, in seconds, is observed. From these two equations, you solve M and A. Here is how one solves for m1 and m2 to finish the characterization of the binary pulsar's orbital parameters. In other words, general relativity never, ever predicted anything about binary pulsars, and they are not tests to general relativity. If they were characterized as such in a grant proposal, the principal investigator lied to the sponsor. The sponsor, who drinks the same Kool-Aid, accepted the grant without a single correction. Does that solve the problem? No. Precession cannot be defined solely by M. If that were the case, it wouldn't depend upon the angular momentum L. The angular momentum L of a two-body Keplerian orbit is given by L is equal to mu times h, where mu is equal to m1 times m2 divided by m1 plus m2. Mu is the reduced mass and h is the specific angular momentum. Here we have the formula for specific angular momentum h and the formula for the real angular momentum L. L depends upon both masses because mu depends upon both masses. Precession ought to depend upon L, and because of that it has to depend upon both m1 and m2. We never question general relativity. It turns out that it has glaring evidence that it is an incorrect model for reality. Einstein's precession formula doesn't depend upon mu or m1 and m2. It only depends upon m. Upon inspection, it becomes clear why GR is wrong. The reason is that it cannot replicate the dynamical reality. The Schwarzschild metric is a central mass, no wobbling around a center of mass, and there is no use of the second mass m2. In other words, the geodesic doesn't depend upon the second mass in the two-body problem. To represent reality, it would have to depend upon both masses. When I used my theory to predict the precessions using as input the masses m1, m2, and a, determined by the accepted fitting, this is what I obtained. Well, since my theory was all right for planets, one should ask oneself what is different about pulsars. What is different is that pulsars are systems where the two bodies have similar masses, as opposed to 1 and 1/1,000,000th, as in the case of the Sun and planets. That led me to think about the Schwarzschild metric and Einstein's derivation of the precession formula. That derivation is for a system with m1 has zero mass. Only if m1 had zero mass would it follow a geodesic. Well, we always heard the opposite. We always heard pundits telling us that in that derivation, all massive bodies would follow geodesics. It is clear that we have been lied to by self-delusional scientists. The reason is clear. The binary system dynamics should depend upon angular momentum. Angular momentum is a function of both masses. Any model that represents the binary system will have to depend upon both masses. Period. Upon inspection, it was clear that my predictions were multiples of the observation. This was an indication that the observed period was wrong. Not by 1% or a microsecond but by 100% or more in certain cases. This can only happen if the number of lobes is more than 1. Representing a higher number of lobes means multiplying the PB by n_lobes. This can be done by scaling both m and a by n_lobes. That doesn't change Einstein's prediction for radians, orbit. It changes GR prediction in degree per year. That is why there is a shift in GR prediction in the next plot. Here we have the binary pulsars modeled using Who instead of general relativity. Einstein's predictions shifted because of the period is now PB times n lobes. I added another factor, 1r, to reflect the fact that Einstein's prediction is only valid for r equals 0. That is how wrong Einstein's theory is. Einstein's general relativity, lauded for 120 years, as the best theory, cannot model a simple two-body system. It only works if the second mass is 0 or very small with respect to the other. In other words, the world has been fooling themselves for 120 years and counting. I say that because most theoretical physicists will not confirm or challenge my assertion. It is simple. Just look at Schwarzschild metric and its use in the derivation of the precession formula and show me the M2 dependence. There isn't any. QED. Here are the signal production for binary pulsars as a function of their orbital phase. Who predicts complex coupling between orbital angular momentum and spin? That is expected since Who's law of gravitation also produces gravitomagnetism and the spinning pulsar can be thought of as a spinning magnetic top. Notice the angular positions corresponding to the pulsar blips. Those blips are used to derive the period. It is clear that when n lobes equal 1, the period of the blips matches the period of the orbit. When n lobes equal 1.5, each blip matches only 2/3 of the orbital period. In other words, if astronomers don't use my theory, they will not know what is happening in the universe. It is that simple. When n lobes equal 2, each blip matches only half the orbital period. When n lobes equal 2.5, each blip matches only 2/5 of the orbital period. My theory also properly deals with the binary black hole GW231123. While general relativity thinks that all falling bodies are magically standing still on the event horizon, despite LIGO signal telling you otherwise, my theory predicts their velocity across the event horizon all the way into the surface of the other black hole. Who not only predicts the dynamics of orbiting black holes but also predicts the dynamics of orbiting and spinning black holes. With Who, a spinning black hole becomes a gravitomagnetic top. No other theory can do this. Many crackpots claimed they understood gravitomagnetism. Their way to it was by analogy. Maxwell's equations tells us that currents generate magnetism, hence, mass current generates gravitomagnetism. That is dandy, but that is not science. If you just say that and cannot back your empirical formulas with a single example, that claim is nothing more than a premature ejaculation. Before you celebrate gravitomagnetism, you have to derive the laws, like I did. Find a system where gravitomagnetism is present. I found the binary pulsars and the binary black hole GW231123. In my theory, I derived the maximum density in the universe. This means that my theory predicts when gravitation creates a region of asymptotic freedom. That region is twice larger in nuclear particles. In who, black holes have surfaces and volumes. One cannot use gravitomagnetism if your top is a singularity. In other words, gravitomagnetism couldn't be discovered before who. Who proposes that black holes are time crystals where the lattice is Compton wavelength of a hydrogen atom or 1.32 femtometers. Hence, who is claiming its rightfully position in science. I also replaced the Big Bang model, created a 3D map of the observable universe, and extracted the initial 4D sound that resonated across the universe, responsible for the CMB. I also solved the Great Attractor, the faint young sun paradox, and the spiral galaxy rotation curve paradox. I also recreated quantum chromodynamics and QED. It is amazing that scientists wouldn't ask me how did I do it. The explanation is that they are not concerned about humanity. They are concerned about copying my work and front-running me. Here, I used the Pantheon supernova survey to solve the crisis in cosmology, Hubble tension. In other words, I did a lot and yet I am not allowed to publish my work. This is not a small achievement. The 533 scientists in the Pantheon survey couldn't do it. Dr. Adam Rees, Nobel Prize in Physics failed, despite of getting the Nobel Prize. In other words, it is relevant and should be part of the conversation. I need your help. Cheers, Marco Pereira. Were you able to understand it? Do you have any questions or comments? Cheers, Marco Pereira. Well, I don't know if you were able to read it, but the image tells that Marilyn Monroe told Einstein that they should have a baby. It might come with Einstein's intelligence and Marilyn's beauty. Einstein, being an ass, replied, "It might come with my beauty and your intelligence." That is why Einstein never got to second base with Marilyn. He has only himself to blame. This proves what we all knew. Einstein was a pompous moron. Come on, astrophysicists, come and defend Dr. Albert Einstein. What else can I say to generate some outrage here? Don't make me be the bad guy. I am just correcting something that needs correction.